Okay, so keeping going with this problem then, what happened was B stays the same, 134.4. C is now shorter, as you can tell. And then if you take 180 minus these two, you get 15.58 up here. So now I can do the law of sines again, keeping these numbers in my calculator, not rounding. I can do the sine of the 15.58 number divided by its opposite side, which is the side I'm looking for, the new side C, equals the sine of 30 over 7 again, I'll use. So now I'm going to solve this for C, and I get 3.76, which makes sense that it's smaller. Okay, for the next problem, for each of the following combinations, we want to know if there's 0, 1, or 2 triangles. So we have an acute triangle, and we know side A is 12 in the first one. So let me draw this. And side B is 10. So that's not a very good picture. Let me redraw it real quick. All right, this is better. Where side 12 is longer. Now, if this side's longer, you can't swing it and move it, because when you do, it comes down over here and it's gonna be longer and it won't make a triangle. So, you can't make the 2 triangles. So there's just gonna be 1 triangle for the first one, and that's what the notes said as well. Okay, so if you find the height of this triangle now, what you'll find is the height is 5. And it turns out that we can make 2 triangles from this then. We could swing this leg over here and make a second triangle over here. So I'm going to put 2 triangles here. Now, you might remember this from the notes. If you go back to the notes, this was what I gave you for this right here. If the height of the triangle is smaller than both legs, and it's an acute angle here, you can make 2 triangles there. So there's different ways to get to that answer, but that's probably the quickest and easiest way. So if I do this last one here, when I draw this side's not long enough to make a connection with the other side. So if you try to do the law of sines, for example, you'll get an error, which means there's 0 triangles that can be made with each side. Okay, the next problem says a flagpole at a right angle to the horizontal is located in a slope that makes an angle of 12 degrees with horizontal. I'm going to draw this real quick. Okay, so you should set up your picture like this. This is a 12-degree angle. The flag is going straight up and down. So if you were to, I guess, extend this triangle down here like this would be a right angle, then this would be a 12-degree angle right here. So you could use that information to find this angle up here, which gives you a 58-degree angle up here. Therefore, then I can use that to find this third angle over here, which is 102 degrees right here. So now I can use the law of sines to find what they asked for, which is the height of the pole. That's this distance x right here. So I'm going to do the sine of 58 over its opposite side, 16, is equal to the sine of 20 over its opposite side, x. This is something you could solve by cross multiplication, in which case you get x equals. I actually have to redo some of these angles because of this. It says the angle of elevation is made with horizontal, not with the ground. So when I do this triangle, I said that the 20 was the angle right here, but really it's the whole angle here. So I have to do 20 minus 12 to get the angle that's inside of here, which 20 minus 12 gives you 8. So this angle inside of here should be 8. In which case, if this is 12, this is 8, and this is 90, this angle up here would be 70, and this would be 102. So now I can do the same thing over here. It's just that I need to change this angle right here to 70. And then the sine of 8 would go here. So that'll work. This gives me about 2.37 meters. Okay, the next problem says you're given a triangle with angle A as 48. So I'm going to draw that acute angle here. And then it says angle B, which I'll draw it down here, is 21. And it says C, side C is 5. Okay, there's only one triangle that can be made here because this is angle side angle that I was given. And that's a triangle congruence theorem from geometry. So I'm going to find this other angle, which is 111 degrees. And then I'm going to do the sine of 111 over its opposite side, 5, equals, and I want to find side A and side B. So I'll do first the sine of 21 over its opposite side, B. I'll cross multiply and solve for B. And that gives me 1.919, keeping 3 digits. And then I'll just do the same thing with A. I'll just change this to A and this to A. So sine of angle A, which is 48, over side A. Now I can solve for side A here, which gives me 3.980. Okay, the last problem then tells us that we have an angle of 70 here. So I'm going to draw that. And then side B is 4, and side C is 5. So This gives me side angle side. Side angle side, there's only one triangle you can draw as well, because that's a tricongruence theorem from geometry. So I can just go ahead and find A by using the law of sines now. But first I have to find angle B, or find another angle. So I'm going to do the sine of 70 over its opposite side equals, and it looks like if I try to do the sine of angle C over its opposite side, every time I set this up I have two missing variables. So unfortunately I'm not going to be able to use law of sines here. So I'm kind of getting ahead to the next section. This is going to have to be law of cosines, which we'll cover in the next section. So I kind of put this problem in the wrong homework assignment, but it's good practice for tomorrow. The law of cosines is, if we're looking at angle A here, then it's going to be A squared equals B squared plus C squared minus 2BC cosine of angle A. So in this case, I'm looking for side A, and B is 4. 4 squared is 16. C is 5. 5 squared is 25. Minus 2 times B times C times the cosine of angle A, which is 70. So I can take the square root of both sides of this, and this gives me side A, which is 5.23. All right, I hope this helps.